This is Geometry, Unit 7, Day 3, talking about using similar polygons. This is the second lesson, so Part B. One thing we've learned in the past is about a dilation of a polygon. That's when you multiply variables by a common scale factor. So you're multiplying the x values by your scale factor, and you're multiplying the y values by a scale factor. It makes it physically larger or smaller depending on the scale factor. Here we're looking at the perimeters of two polygons. So if two polygons are similar, then the ratio of their perimeters is equal to the ratio of the corresponding side lengths. Not only do the side lengths grow with the same ratio, but the perimeters grow with the same ratio. Let's take a look at another example. If we can just call it a rectangle. We have a rectangle, and we'll pretend that this side might be 3, and this side might be 5. Okay? And if we have a different rectangle here, call it a larger rectangle, we'll say that maybe it's twice as big just for fun, so 6, so times 2, so this side we'll say is times 2, and opposite sides are congruent, and opposite sides are congruent. So because the angles are congruent and the sides are proportional, we know the two rectangles are similar. We can also look at their scale factor. So their scale factor is 3 to 6, which reduces to 1/2. And that's true between any of the corresponding sides. Now let's look at the perimeters. This adds up to 8, 11, 16. This adds up to 16, 22, 32. And that would reduce down to 1/2. So the perimeters also have the same scale factor as any of the sides. So here we have a perimeter of 32. Here we have a perimeter of 16. Okay, so it sounds like everything grows at that same proportion. Let's look at the area. The area is 3 times 5, which is 15. But when we look over here, the area is 6 times 10, which is 60. Notice it doesn't go up by the same. So not everything follows that same scale factor. So now you got to keep in mind what does follow that scale factor. Sides can follow the scale factor. Perimeters, because they're made of the sides, can follow that scale factor. But area does not follow that for similar rectangles. So we're going to come down here. We notice we have our two quadrilaterals, not necessarily rectangles. We don't know anything about the angles. But if you take the perimeters, they're going to be equal to any of the ratio of the two sides. So KL and PQ, LM and QR, MN and RS. You can also throw in another ratio in here for the fourth pair of sides, so that the perimeters, when you add up all the sides, that's going to be equal to the ratio of any of the corresponding sides. So here we know that the two triangles are similar. We don't have to prove that they're similar, but we're going to find the perimeter of the smaller triangle. We don't know all the measurements. One way we could do it is find the scale factor. Okay, that's definitely the first thing we need to do. So we know the one side we're aware of is WX. That's the first two letters. and PQ are the first two letters. So we're going to use that as a ratio to figure out the scale factor. So that makes 40 over PQ is 72. We can divide that by 8. Divide that by 8. 5/9. So the scale factor is 5/9. We could use that scale factor to help us find the missing sides. Make two sets of proportions, solve them out, and we could then add up to figure out our perimeter. There would be a common way to do it. Another way, using the idea that the perimeters share the same scale factor, if we do the math to figure out our ratio, we have 72 plus 63 plus 81 equals 216. So our perimeter is 216. That's the distance all the way around it. Well, we know that the ratio between the two perimeters has to follow the same scale factor. So we can use our scale factor to write out a proportion that's going to help us calculate the perimeter of the smaller shape. The 216, does that go on top or on bottom? Because the 216 is of the larger triangle, because the 216 comes from the triangle with the 72 is on bottom, the PQ is on bottom, so we know that the 216 has to be on bottom. And the perimeter is going to be on top. We would cross multiply, so we're going to have the perimeter times 9 equals our 1080, and divide by 9. So our perimeter is going to equal 120. This is the perimeter of triangle WXY. When we look over here, we have learned in the past that any corresponding segment of similar triangles will also have the same scale factor. Well, here we learned that if you go from a vertex to the midpoint of the opposite side, then you're called a median. Alright, that's a median there. So the medians should hold the same scale factor between the two triangles. We first need to figure out what the scale factor is. Find the scale factor. Well, we got to find corresponding parts. We know that WY, the first and last letter, is supposed to correspond with the first and last letter, which is PR. WY is going to be 24 plus 24, which is 48. And PR is going to be 16 plus 16, which is 32. And we divide both of those by 16. And we get our scale factor of 3/2. Now, what we're going to do is use that scale factor to find the missing median. Now, some people like to ask about the 24 and 16. You could use the 24 and 16. That was a you could see you could reduce these into 24 and 16 by dividing both of them by 2. You would have gotten your value of 24 and 16. Then we divided it by some more to get it all the way down to 3 and 2. So because they were divided by the same amount, you're welcome to use the 24 and 16. I just want to be sure you're not just grabbing any numbers and making fractions out of any numbers. You're actually using the rules that we have discussed in class. Corresponding parts are what we should be listing. So the 3 over 2, the 3 came from the 48. The 48 came from the bigger triangle. So the 39 is part of the bigger triangle. The 2 came from the 32, which is a smaller triangle. That is QS. And we're trying to figure out QS. So we'll cross multiply. And we get 3 times QS to equal 78. And we get our QS. 3 goes into 7 2 times with 1 left over. 3 goes into 18 6 times. So QS would have to be 26. Here we have a large cement court being poured for a basketball hoop in place of a smaller one. I kind of think about this like a summer club or something like that. You're making the court bigger. The court will be 20 feet by 25 feet. The old court was similar in shape, but it was only 16 feet wide. We're not sure how long it was. So if we draw the pictures, we have the older shape, which was 16 feet wide. We see that the long and the wide's a little shorter. So our width and our length, we know that the 16 represents how wide it is. Then we have the newer court that is larger. They say that the length of the newer court is 25 and the width of the larger court is 20. What we're trying to figure out is what proportionally was the old court's length. Well, the new court is 20 feet wide and 25 feet long. The old court was 16 feet wide, and we don't know yet how long it was. We put an L. Well, you can use this idea. Before we solve for the missing sides, we can use this idea already to help us figure out perimeter. We know that perimeter is twice the width plus twice the length, because a rectangle has 2 lengths and 2 widths, and to measure perimeter you have to go all the way around the shape. So our perimeter is going to be 2 times the 20 plus 2 times the 25. The perimeter is 40 plus 50, which equals 90. So to find the perimeter of the old shape, we don't even have to know all the measurements. We just need to know what their scale factor was. Their scale factor was 20 over 16. We can divide both of those by 4, which is going to give us 5 over 4. That's our scale factor. So now we can do 5 over 4 to equal 90 over the perimeter. And we cross multiply. So we get 5 P equals 360. And 5 goes into 36 7 times with 1 left over. So we get 72. That is our perimeter of the smaller shape. So notice we can calculate the perimeter even though we don't know all the measurements all the way around it. And we can, of course, solve for the missing side. We still know the scale factor is 5/4. We know that one side was 25 and the corresponding was our L. So we have 5 times L to equal 100. So the missing side length was actually 20. And that would be feet. So at our perimeter, it would be considered feet. Our last example. Here we have two triangles. We know that the two triangles are similar to each other. We can look here. This is called a similarity statement. Triangle BCD is similar, that's kind of a squiggly line there, to triangle RST. BCD is similar to RST. If you're similar, remember, that means that your corresponding angles are congruent and your corresponding sides are proportional. So what we're going to do first is find our scale factor. Remember, we know that the triangles are similar. We don't have to prove that they're similar. We know that they're similar, so we can go right to our scale factor. So we're looking at sides that are going to match up. So BC is the first two letters. RS is the first two letters. We can use that as our scale factor. BC over RS, that's going to reduce, or we plug in our numbers, to get 12 over 24. Of course, we can divide each of those by 2. Actually, we can divide each of those by 12, and we are going to get 1/2. So our scale factor is 1/2. So you can probably mentally figure out what ST is really quick, letter X. But we're going to say our scale factor is 1/2. We're trying to figure out ST, which is the X variable. ST is your last two letters. It corresponds with CD, the last two letters. CD is 13. CD would go on top of the triangle because that's where BC was located. That's where the smaller numbers were located. So we have our 13 over our X. We cross multiply to figure out that X is going to be 26. Good luck.